Hi guys, this is section 8.3, homework number 2. In this problem, we're given a set A which contains the following integers. And R is a relation defined as follows. For all x, y in A, x is related to R, so x is related to y, which is x, R, y. If and only if 3 divides x minus y, so 3 divides the difference of x minus y, which means x minus y has to be a multiple of 3. Basically, that's what it means. Now, first of all, let's find the equivalent classes for the following. So the class of 0, class of 1, class of 2, and class of 3. Now, here comes the definition of equivalence class. So we define equivalence class, say in this case, the class of 0 will be the collection of the elements from A. We are talking about set A, right? So will be the collection of the elements from A so that this element is related to 0. That's how we define the equivalent classes. So now, of course, let's look at how the relation is defined. X is related to y if and only if 3 divides the difference of x and y. So in other words, this is the same as saying, well, what are the elements in A that we're looking for? They are the elements so that 3 divides x minus 0, right? 3 divides x minus 0, or this is the same as saying we are looking for the elements so that 3 divides, by the way, x minus 0 is just x. So this is basically just x. So 3 divides x. Basically, 3 divides x means x is a multiple of 3. So x is a multiple of 3. So now, time for you to skim through the elements in set A. Just identify which number is divisible by 3. So we can certainly quickly go through that. Not negative 4. Negative 3 is divisible by 3. The result is going to be negative 1. So, right? So therefore, negative 3 is one of those. 0 is divisible by 3 because 3 times 0 is equal to 0. So 0 is divisible by 3. And the next one is 3. So that's the class of A. So it has 3 elements. Now let's look at class of 1. Again, I'm going to just quickly write this out. So x, we're looking for the elements in A so that x is related to 1, right? Which means x 3 divides x minus 1. So that's what it means. 3 divides x minus 1. Now a quick so when we say 3 divides x minus 1, that means x minus 1 is equal to 3 times some integer. Let me call it n, okay? So which means x is equal to 3n plus 1, right? So basically it's multiple of basically if you look at when you divide by x, the remainder has to be 1, right? Because so basically x minus multiple of 3 is going to be 1. So when you divide x by 3, the remainder is going to be 1. So therefore keep that in mind. So this means x is going to be 3n plus 1 for some n. For some n. Okay? Now let's take a look at, like, will negative 4 be one of those? You're going to just try. So negative 4, will it be 3n plus 1 for some n? That means when you add that, this will be when you subtract 1 to both sides, we will have negative 5 equals 3n. Will you be able to find such integer? No, definitely no, right? So therefore negative 4 should not be. Negative 3 is not, because negative 3 is just a multiple of 3. There's no remainder 1. So similarly, negative 2, let's take a look at negative 2. Okay, let's take a look at negative 2. Okay, so negative 2 is negative 2 equals 3n plus 1. So that's minus 1, which is 3 equals 3n. Yes, there is a, when n is 1, when n is 1, when n is 1, sorry, I made a little, this is supposed to be negative 3, right? So therefore n is negative 1. When n is negative 1, we get negative 2. So negative 2 is related to 1. Now, and then you do repeat this. Will negative 1 be related to, will negative 1 be related to 1? You just check, will negative 1 plug in negative 1? Are you able to find such integer, right? There's no way that you can find this integer. So if you repeat this, the next one in the list is actually going to be 1. Okay, going to be 1 because when n is 0. And the next one you can try is when you plug in n being 2. 2 times 3 is 6, 6 plus 1 is 7. However, we do not have, I'm sorry, we try that when n is 0, we get the 1. When n is 1, I skip that 1. So when n is 1, so 3 times 1, which is 3, 3 plus 1, which is 4. So 4 should be in it. When n is 2, so 3 times 2, which is 6, 6 plus 1 is 7. 7 is no longer in this set. So I think that's all. Right? So we talked about how to identify, right? Another way for you to quickly do that is for some n, you can just trial and error. When n is negative 1, you see a negative 2, right? When n is 0, you see a 1. When n is 1, you see a 4. So you can quickly find those numbers in this class. Now let's find 2. Hopefully you can pause the video and give a try for your, by yourself. So if you resume the video, and this is how I will find the class of 2. So will be the elements of x in A, elements in A, so that x is related to 2. According to how we define it, that means 3 divides x minus 2, right? Okay. Now I'm gonna again explain what that means here. So 3 divides x minus 2 means x minus 2 is a multiple of 3. That means x equals 3n plus 2 for some n. Now, so I'm going to say x is 3n plus 2 for some n, okay? And then again, using the trick, you can try and error. So when x is, say, negative, try the negative first, okay? Try the negative first. When x is negative 1, so do a little algebra. 3 times negative 1 is negative 3. Negative 3 plus 2, which is negative 1, right? So I know negative 1. Let's try negative 2. So when n is negative 2, negative 2 times 3 is negative 6. Negative 6 plus 2, which is negative 4. Okay, I'm not going to try negative when n is negative 3 because I see negative 4 is the smallest. So I would not bother to try n negative 3. Now I'm going to try n being 0. So when you plug in 0, this is going to be 2. So 2 is in here. When you plug in n being 1, 1 plus 1 times 3 is 5. 1 times 3 is 1. 3. 3 plus 3 is 5. I meant to say 5 in my head. Okay, so I think that's all. And then when you find the equivalent class for 3, I already see, by the way, 3 is in here, okay? 3 is in here. You know, being equivalent class, it has to satisfy 3 different requirements, conditions. One is reflexive, symmetric, and transitive, right? In other words, I know 0 is related to 3, and 3 has to be related to 0. So I know that they must have something in common here, and it will turn out they will be identical actually. All right, so but obviously the book actually wants you to try, right? So therefore you certainly welcome to try. I know it's going to be the same as the class of 0. So x in A, 3 divides x minus 3, okay? And 3 divides x minus 3 means x minus 3 equals 3 times some integer. That means x equals 3m plus 3. So means x equals 3m plus 3, some integer n. And you try again. When n is 0, you get 3. You get 3 when n is 0. When n is negative 1, you get 0. When n is negative 2, you get negative 3, right? And that's all you have. And you can see that these two are actually identical. So therefore, how many distinct equivalent classes that we have? If you count, we have actually, I think we have 10 numbers in class A. And let's take a look at how many, like the size of each class. There were 3 here, 3 here, and 4 here. 3 plus 3 plus 4, exactly 10. So therefore, all those elements in A, they are separated into these 3 different classes. So we actually have 3 distinct equivalent classes. And what they are? So list the distinct classes of R. They are actually these 3. The class of 0, which is negative 3, 0, 3. And class of 1, negative 2, 1, and 4. And class 3, class 2, class 2, which is negative 4, negative 1, 2, 5. So yeah, that's how I would solve this problem.